On to question number 6. The reaction of chromium oxide, I believe, with silicon metal, high temperatures will make chromium metal. And then they have the reaction for us. The reaction is begun with 197 grams silica and 135 grams of the chromium oxide. How many grams of the excess reactant are left after the reaction is complete? This is just a classic limiting reagent question. So the first thing I'm going to do is write out the balanced equation. So it's given to us, so I don't have to balance it myself. Just gonna separate what we know from the chromium oxide reactant and the silica. So we know the mass of silica is equal to 197 grams. And I'm also going to write out the molar mass of silica below it. If you were to look it up in the periodic table, you'd see it's like 28.009 grams per mole. And then to calculate for the number of moles, it's going to be mass over molar mass. And then you end up with around 7.01 moles. So now let's do the same thing for the chromium oxide. Its mass is 135 grams. Its molar mass is 151.99 grams per mole. Then if we are to calculate the number of moles involved in this reaction, you only get 0.888 moles. Okay, so we look at the number of moles for both of these, but we also want to take into account the mole ratios in the balanced reaction. So we see that 2 moles of the chromium oxide is needed to react with 3 moles of the silica. So I'm just going to write over here. The ratio is 2 to 3. And we can already kind of tell that the chromium oxide is our limiting reagent. There's simply not enough moles for it to react with the 7 moles of silica. So now I'm going to calculate the moles of silica that we have left after the reaction is completed. And to do that, it's going to be moles of the silica initially minus however many moles reacted with the chromium oxide. So we know that it started off with 7.01 moles initially. To calculate the moles reacted, this is when you would take into account the mole ratios. So we know that 3 moles of the silica reacted with 2 moles of Cr2O3. And then this is going to be multiplied by however many moles of the Cr2O3 there was, which was the 0.888. So whatever you're looking for, like in our case it's the silica, it's going to be on top, and the one that you want to cancel out is at the bottom. So you'll notice that these units should cancel out. And then if you do the math and do the 7.014 moles, subtract whatever we get here, you're going to end up with 5.68 moles of silica left. So now the question is asking how many grams of excess reactant are left. So part 2 of this question is just finding the mass. All you're going to do is multiply the number of moles times the molar mass. So we know it's 5.68 moles. The molar mass of silica is 28.09 grams per mole that I wrote up there. So the mass left over is 159.08 grams. So if we look at the answer from our junior tutor, they did the exact same thing. Okay, so let's